How to simplify rational expressions, division and multiplication. Coming up, back into action. Hey guys, this is another episode on simplifying rational expressions. And we will be focusing on multiplication and division. If you are up to just simplifying rational expressions and addition and subtraction, please check out the previous episodes from 1 till 3. Now, as a good rule of thumb, multiplication and division could be treated as we would normally treat numerical fractions. So for multiplication, all you need to do, as a good rule of thumb, you multiply tops straight across and you multiply bottoms also straight across. So basically what you would get is just, for the first one, 5a times 9x cubed. This is your top, and your bottom becomes 36x squared times, I will just write it as a just dot in order to not confuse with x. Now, at this point, check to see if you can reduce the resulting fraction to its lowest term, because this is important, and you always want to get your final resulting expression or final resulting fraction into the simplest form possible. So to do this, just check to see if there any common factors to both top and bottom that can be cancelled off. So yes, there are. So ask yourself, do top and bottom share any common factors that can be cancelled off? Alright, let's start with numbers. Since 5 goes into 25 5 times, so we could reduce these numbers. Same goes for 9 and 36. So 9 fits into 36 4 times. Now, you have a on top and you have a squared on bottom. So as well, you could do simplifications with a. So you would be left with a on bottom. And with x squared, since you have x cubed on top, you would be left with just x on top, and x squared is gone from bottom. Your simplified fraction, your lowest term for this problem would be just x on top. 4 times 5 we could multiply together, so 20, and you have also a on bottom. So this is your final answer for this problem. Moving on, how about this one? Alright, so the same idea, stick to the same rule. You want to multiply tops across and bottoms across. Alright, moving on. One little tip. You don't have actually write them as a single one fraction and combine your tops on top and your bottoms over there. So actually you could start with cancelling at this point, so it would just save your time and paper. So because like you can do this cancellation over there, like 9 goes on 36 4 times and blah blah blah, so like this. So just from the beginning, you can. For example, here, because we have multiplication, we could reduce by 7, so, and we could reduce by y, so actually y and y cancel each other out. Now, another thing is sometimes you need to factor out your rational expression. You need to factor out as much as you can, and after factoring, something might cancel. For this one, this is binomial 3x plus 6, but if you look at this carefully, it can be factored out. Since 3x and 6, both terms, they are divisible by 3, and 3 can be taken out outside of the parentheses and placed outside. So let's rewrite what we have. So just one fraction, we still have x plus 2 on top, and on bottom I'm going to take out this 3 and place it outside of the parentheses. What's left over? X plus 2. And you could check your factoring at this point, since 3 times x gives you 3x back, and 3 times 2, they would take you back to 6, so that's fine. And here we have also two left over, so times 2. And now we have this term, we have this x plus 2 that basically can be cancelled. So we could just eliminate and cancel this x plus 2. So now at this point it's not that obvious that you can cancel something else. But when you factor as much as you can, as I said, some common factors might appear, might occur, that why you could cancel more. So you would be left just with 1 on top, and these two constants need to come together. Since 3 times 2 gives you 6, your final answer would be just 1 over 6. So this is your final answer. Alright, let's dive into division. Alright, as a rule of thumb here, when you perform a division, the first thing, you swap division to multiplication, followed by taking the reciprocal of the divisor, and then proceeding with multiplication. So this is a rule of thumb. All we need to do is just stick to this. So let's do it for the first one. So the rule says you keep your first fraction as is, so just rewrite it for now. Now you swap division to multiplication, and for the divisor, for the second fraction, which is called divisor, you need to invert it. You need to take the reciprocal. Means you need to simply switch top and bottom, swap top and bottom. So 3y squared goes on top of your fraction, and 2y minus 1 goes on bottom. Now we rewrote our division problem into multiplication, and now all we need to do is just proceed with multiplication the same way as we did the previous two examples. So for multiplication again, check to see that your top and bottom have something in common that can be cancelled off. And also keep in mind that you have to factor out everything as much as possible. So since 8y minus 4, these both terms of this expression contains 4, 4 can be taken out and placed outside of the parentheses. And what's going to be left over? So you would be left with just 2y minus 1. So here we would have just 2y minus 1. Since the first term, this is nothing, we could ignore it. And we have still y. Now you could cancel this 2y minus 1. This is the common factor. And because we have multiplication between the terms, point when we do this cancellation, granted that we can impose the condition that your 2y minus 1 is not equal to 0, because we are getting the lowest term, we are getting the fraction which is equivalent to the first one. So we should list out the values that have to be excluded, they have to be thrown out, they have to be cast out. This expression would have made the denominator equal to 0. That would make our denominator undefined. So your entire algebraic fraction has no algebraic meaning. So that's why we have to impose, so provided that, granted that this bottom is not equal to 0. So we could do this side calculation and we could solve it for y. It's very basic kind of equation or inequality, because actually it's not equation, it's not equal, but anyway we just move one to the right side and you would be left with y is not equal to 1 over 2. So this is our condition, this is our excluded value or restriction if you like. So, and granted that we imposed this condition, this excluded value, we would write our final answer as, so we have just for y. And since you have nothing on bottom, your bottom actually is 1, so we could just leave it out. And your final answer is just for y, provided that. Moving on. Alright, you have trinomials, and at the first glimpse, at the first sight, there is nothing that can be cancelled out. Nothing. Since you have trinomials and there is nothing that can be pulled out front, because sometimes even if you have trinomials, sometimes the terms contain a common overall factor number that can be pulled out. So in this case, just check it by observation, there is nothing. But you can factor them out. You can use factoring techniques to break them up into two sets of parentheses multiplied together. But let's begin by just implementing this division. So let's just divide according to our rule. So let's just switch it to multiplication. So you keep the first fraction as is for now, and later we will factor it out. Now you swap division to multiplication, and for the second fraction, you want to invert it. You want to take the reciprocal. Basically, that means you switch your top and bottom. So this expression goes on top, x squared. And your top becomes, your old top becomes new bottom. Alright, we got rid of, let's say, division. Now, as I said, there is no overall constant, there is no overall terms that can be pulled out. So at this stage, all you need to do is just factor them out. Since the leading coefficient of all of these four trinomials is 1, it wouldn't take that much time, and you don't make that much effort to factor them out, because if your leading coefficient is not 1, it's a little bit tedious to factor them out, but still feasible, still doable, and we can do it. And for factoring, if you're up to it, please check out my videos on how to solve quadratics with factoring and with magic act. So these techniques, actually, I'm going to use it here. So all you need to do is just break your expressions into two sets of parentheses, multiply together. This is for the first one. So both starting with x, and you are looking for two numbers, to put it in a nutshell, that they multiply to 6 and they add up to 5. And since 3 and 2, their product gets to 6, and their sum 3 plus 2 give you 5, so your factors gonna be x plus 3 and x plus 2. Now, we could actually write the same bar, the same division line, but let's keep it like this, because anyway, I hope we will be able to cancel something. That's actually what we want, what we're aiming for. Let's look at the bottom. So again, you have two sets of parentheses, both starting with the x, the variable you are given. And now we're looking for two numbers that their product gets to -4. So it's gonna be 4 and -1. Basically, you could swap the order as well, doesn't matter at that point. So for the top polynomial, so the same idea applies here. So their product of these two numbers gets to -5, and their sum is 4. So basically they are gonna be 5 and -1. Since 5 times -1 gives you -5, and 5 minus 1 gives you 4. And finally, the last one. Basically, it's a kind of perfect square, since perfect square comes out there, since 4 is a perfect square, so you would have just x plus 2 times x plus 2. It can be repeated root in this case. And we are done with factoring at this point. We are done. We are completely done. Now, something hopefully would cancel, and check to see. Yeah, we are very, very lucky today with you guys. Maybe I'm lucky today. So x minus 1 and x minus 1, you just cross it, because everywhere we have multiplication. This is totally legal. This is fine, and we can now proceed with cancellation. And also x plus 2, I believe, also would be cancelled out. So you would be left just what's left over. We have x plus 3, nothing else done with cancellation. So x plus 3 on top and x plus 5 that's left over on top. And what's left over on bottom? So you have x plus 4 and second parenthesis x plus 2. About excluded values, if you ask me, so we could write excluded values. So that basically comes from this term. When we cancel by x minus 1, so basically your x cannot be equal 1. About x plus 2, so when we cancel by x plus 2, so x cannot be equal negative 2. So basically it comes from there, and it's obvious when you look at your expression. So you don't need to write x is not equal to negative 4 and x is not equal to negative 2, because basically this expression implies that. So it would be kind of overkill. But that x is not equal to 1, it's not that obvious, but because we remove this x minus 1, we remove this term from our fraction, so we have to just state it, like, to be safe, that your x basically cannot be equal 1. So otherwise that would have made your denominator undefined, that would have made your denominator equal to 0, and that would have made your entire fraction undefined, that your fraction in this case has no algebraic meaning. So we are done with that. Well, I hope it helps you. Train your brain, and thanks for watching. I know everyone hates maths, but if you like my video, please hit like, share with your friends, leave the comment down below, and be sure to subscribe so you will not miss my new videos.